Hello and welcome. I am Vaibhosha and our today's topic is projection of points. So let us begin. First, the notations. So following are the notation which should be followed while naming the different views in orthographic projections. So let us suppose in our case our object is point A. So we will be giving its top view a notation small a. Its front view would be denoted by A with a single dash and its side view would be denoted by A with a double dash. So these are the notations which we are going to follow throughout the chapter. So now before starting with the chapter, let us first understand the quadrant system. So as you can see, you are having two planes here. One is your horizontal plane, or you can say HP, and second is your vertical plane, which is shown by a blue color, or you can say VP. So horizontal plane is a plane which is parallel to your earth surface or earth crust. It is known as your horizontal plane, and plane which is perpendicular to your horizontal plane is known as your vertical plane. So by intersection of these two planes, we are having one quadrant system generated, which is nothing but your mathematical quadrant system, and which is separated by your XY line, as you can see. So by intersection of HP and VP, we have total 4 sections generated. First is known as first quadrant, second, third and fourth. So we have total 4 quadrants which are generated solely by intersection of horizontal plane and your vertical plane. So let us suppose if we try to put any object into your first quadrant, and if we try to observe that object from this direction, then we might have its front view of that object. Front view means we are observing that object from the front direction. So now let us suppose if we are observing the object from this direction, and if we are having the front view of an object, then we might get this front view on your vertical plane like this. Now if let us suppose we are taking now top view from the top direction, so our object is placed in first quadrant itself, and now we are taking the view from the top view direction, then we might have its top view projected on your horizontal plane. So always remember, whenever you are taking the front view, then front view would always lie on your vertical plane, and whenever you are taking the top view, then top view would always lie on your horizontal plane. So now let us suppose if we try to convert this 3-dimensional quadrant system into 2-dimensional quadrant system, then what to do? So let us observe the procedure. So now I will try to observe this quadrant system from this red arrow direction. And while observing this quadrant system from the red arrow direction, what I can see is a big doctor's plus. So let us begin and let us draw your 2-dimensional view of this 3D quadrant system. So what we'll have is, we'll be having one vertical line like this. It will represent your vertical plane or VP while looking it from the red arrow's direction. We'll be having one horizontal line like this. It is nothing but your horizontal plane while we are looking from your red arrow direction. Now the intersection of these points HP and VP would give us nothing but what? Your XY. So when you are observing your XY from the red arrow direction, then your X and Y point would coincide at a same point. So we'll be having the intersection point here as your X and Y point. So let us denote this vertical line as VP now and your horizontal line as HP. After that, let us define the quadrants in this plus. So this first quadrant would be, this first point would be your first quadrant. The second section would be your second quadrant, this would be your third quadrant, and this would be your fourth quadrant. So we have now defined the 4 of the quadrants, and we have now converted our 3D quadrant system into now a 2-dimensional plus or a 2-dimensional quadrant system. And let us suppose if we try to place our object here now in the first quadrant, and if we try to take the front view from this direction, then we might have our front view on this vertical line or a vertical plane. And if we try to take its view from the top view direction, it is obvious that we will be having its top view on our horizontal plane here. So let us begin and let us try to understand the quadrant system in detail. So here we have possible positions of a point. So in space, remember, in space we have total 9 possible positions of a point available. So you can't have more than 9 positions of a point in a space. So before moving ahead, let us understand the quadrant systems once again. So quadrant system is once again made up of two planes. First is your horizontal plane, or it is also known as your HP, and second plane, it is also known as your vertical plane or a VP. So now the portion in front or this direction would be denoted by in front VP, and the portion on the back side of your VP would be denoted by behind VP. As you can see, the portion just above your HP would be denoted by above HP, and portion which is below HP would be denoted by below HP. So try to get these things in mind. The portion which is in front or on the right hand side of your vertical plane would be what? In front of VP. Portion on the back side or the left hand side of your vertical plane would be behind VP. The portion above or upper side of your HP would be your above HP, and the portion below your HP would be known as below HP. So by considering these terms, let us move ahead and check how many positions we are having for the point. So we must be having total of 9 positions available for a point in a space. So first 4 positions are the position itself in 4 quadrants. Like first, let us start with the first position. So point A is in first quadrant, second point B in second quadrant, point in third quadrant, point in fourth quadrant. Then after, we will be having another 4 positions in plane itself, starting with your point E, which is in HP, which is in front of VP, F, which is in HP itself, but it is behind VP. Then after, we will be having EFG. G means the point which is in VP, but it is above HP, and point H, which is in VP, but it is below HP. And then after, we will be having a final point which is an intersection of your HP and VP both. As you can see on XY line, there is one point which is known as your point which is intersection on the intersection of HP and VP, and you can also say it is on XY line itself. So these are our total 9 possible positions available. So let us start with the first point. So first point, it is said that in first quadrant, so this is point A. So we can say that for point A, as you can read from point number 1, it is above HP and it is in front of VP. So it is above HP and in front of VP. For B, we can say that it is above HP but behind VP. For point C, we can see that it is below HP and behind VP. For point D, we can say that it is below HP and in front of VP. So these are our first 4 points. Now let us define another 4 points. So another 4 points, let us start with point E. So point E is on HP and it is in front of VP. Then point F is on HP but it is behind VP. Then point G, which is on VP but it is above HP. Now point H, which is on VP but it is below HP. And then after, let us define the last point which is on HP and on VP. That means you can also say it is on intersection of HP and VP. So that's why point I is on HP and also on VP. So these are total 9 possible points available. If you can understand this, all of the 9 points, then you can easily solve any of the example based on this projection of points chapter. So let us move ahead and let us understand few of the theories of projection of point. So let us suppose if our point A is now in the first quadrant. First quadrant means what? Let us remember our quadrant system once again. So above HP and in front of VP is known what? It is known as your first quadrant like this. So this is your first quadrant. So your point would be in first quadrant like this. It is above HP and in front of VP. So this is supposed your point A. Now if we try to take the projection of point A, then we would understand that how the projections are actually taken for any points. So we will be taking 2 projections. First, your front view from this direction. front view from this direction, and second your top view from the top direction. So let us begin and let us take two projection of each of the different 9 points. So first let us start with the front view. So if we try to take the front view from this observer direction, then we might have point A's projection somewhere there on your vertical plane like that. So now we are dealing with a front view. That means what we should write? A dash, small a dash with a single dash. So we'll be writing down A dash. Now if you try to take the top view of your point A from looking at the top direction of your point A, then we will be having the point here on your HP itself, because top view always lie on what? Horizontal plane. Now we know that it is a 3-dimensional object. So what we'll do here is we'll try to convert this 3-dimensional figure into 2-dimensional line view. For that, what we have to do is we will try to rotate horizontal plane around your vertical plane into clockwise direction. So now what we'll do is we'll try to rotate this horizontal plane in clockwise direction. So that means this point will also rotate with this horizontal plane and it will come here on your vertical line like this. So now your A point would be lying on your vertical line in the place of your horizontal line. So what we have done is we have fixed your vertical plane and we have revolved or rotated your horizontal plane around your vertical plane in clockwise direction. So in order to get both the views in single line, because it is very difficult for you to solve the examples in 3-dimensional views. So that's why we are trying to convert this object into 2-dimensional clearly understandable view, or you can say orthographic views. Now, there would be one question in your mind. Sir, why you have only rotated horizontal plane? Is it possible to rotate your vertical plane? The answer is no. So let me give you a reason that why I have just only rotated a horizontal plane, not a vertical plane. So now, as you can see, on vertical plane, which view we are getting? We are getting a front view. So always remember, if you try to identify any person or any object, you should know its face or front side. If you don't know the front side of an object, then you can't identify what object or what person you are talking to or what person he is. So for that, the front view of any object or any person is very important. That's why we are having our front view always on the vertical plane. So that's why vertical plane is very important for us. So we are keeping vertical plane intact and we will be just rotating always a horizontal plane around your vertical plane like this to have our orthographic views. So it is clear. So now let us move to a point A in the second quadrant. So let us understand second quadrant means a point which would be in second quadrant like this. And the point would be above HP but it would be behind VP. So this is the location of point A from the quadrant system we have just learned. So this is now a new location of point A. Now we will be taking same two views, front view and top view. So let us take a front view. So front view direction would be common for any of the views we are taking for any of the position of points. So we are keeping this direction of front view and top view same. So we will be taking front view of this direction. So when we try to take the front view from this direction, we will be having point A's view on the vertical plane, as you can see. So this will be nothing but what? It will be A dash. Now if we try to take a top view, then it is obvious that top view would be on horizontal plane just below your point, and now we will be converting this horizontal plane or rotating this horizontal plane in clockwise direction around this vertical plane. So when we try to rotate it in clockwise direction, now point A would be on the vertical plane like this. So we will be having two of its views, A dash and A, on the same vertical line but above your HP for the case of point in second quadrant. So now let us move ahead and let us see the case for third quadrant. So first let us understand what do you mean by third quadrant. So third quadrant means something like this. So whenever your point is below HP and it is behind VP, then it is known as your point is in third quadrant. So now let us take two views once again. First is the front view, so we'll be looking object from this direction, so we'll be having a front view. So we'll be having a front view obviously on the vertical plane here. So this is nothing but an A dash. Now let us take the top view from the top direction. So when we try to take a top view from top direction, so what we'll have one point as a top view on HP. But what we are going to do, we'll try to rotate your horizontal plane in clockwise direction, and we'll be having its top view now in what? Vertical line of A. So this is your final top view. So now you can see for third quadrant, your top view would lie just above your horizontal line, and your front view would lie just below your horizontal line or your XY line. So you can see. Now let us move to our final quadrant, fourth quadrant. So let us understand first what do you mean by fourth quadrant. So this is nothing but the location of fourth quadrant. As you can see, in fourth quadrant your point would be below HP and it must be in front of VP. So we'll be taking once again two views, right? So first the front view. So let us take the front view from this direction. So we'll be having one view on your vertical plane like this. So this is nothing but what? A dash. Then after what we will do, we'll try to take a top view from this direction. So let us take the top view. So we'll be having the top view on horizontal plane itself. But what we are doing, we are rotating this horizontal plane in clockwise direction. So we'll be having the final view A like this. So for fourth quadrant, both the views, top view and front view, would lie below your XY line or horizontal line like this. So this was the understanding for your conversion of three-dimensional point views into orthographic views. But you might be feeling that it is very much complex to understand. So you might be feeling very complex to understand, right? Don't worry. So in examination, actually we need not to draw that diagrams. It was just for your understanding purpose. Now we'll learn what we need to actually draw into our examination, which will actually give us some marks. So let us focus into that part. So let's start with the first point. A is in first quadrant. So now here our objective is to draw first the XY line and then denote a front view and top view of point A with respect to XY line. And that is the task which is asked in your examination, and you need to draw just this final figure in order to describe your orthographic projection of any point. So let us see. For point A in first quadrant, so we know that first quadrant means what? So you see on the left hand side table there is written there point must be above HP and in front of VP. So this is the location of point in first quadrant, right? So now the answer is, so whenever your point is in first quadrant, you need to draw one XY line, and then after above XY line you need to show your A dash, and below your XY line you need to show your A. A dash is nothing but your front view or elevation, and A is known as your top view or plan of a point, right? Very easy. Now, what you need to remember. So always remember, whenever your point is above HP, your answer would be the front view above XY line. Always. Now, whenever your point would be in front of VP, then your answer would be, your top view would be below XY line. So that means whenever your point is above HP, then your answer would be your front view or your point with a dash above XY line like this. And whenever your point is in front of VP, then your answer would be your top view below XY line or your point without dash below XY line like this, right? So now let us move to a second point. So now suppose your point is in the second quadrant. So second quadrant means what? So let us see the table on the left hand side, above HP but behind VP. So this is the location of point in the second quadrant. So answer for second quadrant point would be what? So this must be the answer of second quadrant point. So once again, what you need to do, you need to just draw your XY line, and above your XY line you need to show 2 points, one A dash and second is your point A. So now very easy. So what you need to remember, so whenever your point is above HP, so you know that front view would be above XY line, that means point with a dash would be above XY line. So here it is. Same like previous one, if your point is above HP, then your answer would be what? Your front view or your point with a dash would be above XY line. So then after, if suppose your point is behind VP in this case, then your top view would be what? Above XY line, like in this case, your point without dash would be above XY line. So you need to remember that. So now let us see for point number 3. So point number 3 means what? So let us look at the table on the left. So point 3 means the point below HP and point is behind VP. So this is the case of point 3. So whenever you are having point in third quadrant, then you might be having this as answer. So answer says that, so whenever your point is below HP, then your front view would be below XY line, as you can see. And whenever you are having a point behind VP, then obviously your top view would be above XY line. So without dash, point would be above XY line. Then after, let us look for the point in fourth quadrant. So let us look. Fourth quadrant means what? In the table, so below HP and in front of VP. So whenever your point is in fourth quadrant, this must be your answer, in which what? So let us see in the table. So behind below HP means what? Front view will be below XY line, as you can see. A dash, point with the dash, is below XY line. And next, your point is suppose in front of VP, then what? Your top view would be below XY line. So as you can see, your top view or plan or without dash point would be below XY line. So for fourth quadrant, your both of the top view and front view would lie below XY line. Right? Very easy. So you need to just remember this table, and from this table you can directly find out these answers. Very easy. So let us move ahead and let us see another 4 points for which we will be defining these conclusions. So now point A is in first quadrant, but this time your point would be on HP and in front of VP. So this is the location of our point A, in which what? Point A is now on HP itself, but it is in front of VP. So this is the location of point A. So now let us take two views once again. First is your front view. So let us take the front view from this direction. So the front view always lies on what? VP. So in this case, VP would be the point view, the intersection of HP and VP. So this would be your A dash, because this is the starting point of VP. So this would be your point A dash. After that, what we'll take? We'll take the top view. Right, correct. So let us take the top view of this point, but as your point is already on HP, so you will be having your top view lying on HP itself. Now next step, what? We'll try to rotate this HP in clockwise direction like this. So our final point would be what? Point A on this vertical line. So this is the final projection of a point whenever it is resting on HP, but it is in front of VP. So now let us see one more point. Now point is in second quadrant, but here the point is above HP and on VP. So let us check the position of the point. So in this case, this is the position of a point, as you can see on my left. So this is the new position of a point. As you can see, the point is now what? On VP, but it is above HP. So this is the position of the point. So now let us take the two views once again, front view and the top view. So now let us take the front view from this direction. So when we try to take the front view from this direction, so what happens? The front view always lies on what? VP. So we'll be having the point itself on the VP. So we'll be having point A dash at the same location because our point is already resting on VP. Now if you try to take the top view of this point A, then top view would lie on what? HP. So you will be having your top view on HP itself. So you will be having this point A on intersection of HP and VP, because it is the point on HP. So this is the final view of an object. Now then let us move to our next point. So point is suppose in third quadrant now, but it is on HP and it is behind VP in this case. So what will happen? So let us see. So this is the location of a point, as you can see on the left hand side. So now your point A is resting on HP itself, but it is now behind VP. So now let us take the front view from this direction. So it is obvious that front view will lie on what? Vertical plane. So it would be there on the vertical plane like this. So this is nothing but your front view on a vertical plane A dash. Now let us take the top view of this point. So when we try to take the top view, it would be in the same location because already your point A is on what? HP itself. So that's why your top view and your point would lie on the same point. So this is the location of point A. Now, but what we'll do next, we'll try to rotate this horizontal plane in clockwise direction like this. So we'll be having our top view here somewhere on your vertical line. So for third quadrant point, whenever it is on HP and it is behind VP, you will be having this as an answer. So now let us move to our fourth point. So whenever the point is in fourth quadrant, but in this case it is below HP and on VP itself, so what will happen? So this is the location of your point, and as you can see, it is on VP itself, but it is below HP. So now let us take the two views once again, the front view from this direction. So when we try to take the front view, so you will be having your view on VP itself. So you will be getting the view on the same point because already your point is resting on what? VP. So that's why we will be having your A dash point on VP itself. Now let us suppose if we try to take the second view, the top view from the top direction, then what will happen? So we will try to take the top view from this direction. So we will be having the point view on your intersection of HP and VP. So this is nothing but your final view or top view without dash on the HP itself. So these are the views, but these are the views in 3D. We have learned in 3D. It seems very difficult, right? Don't worry, we'll be just converting these views into clearly understandable figures. And in examination, what you need to remember is this. So this portion you need to remember the table on the left and the final answers which will show here on the right you need to draw. So in examination for your getting marks, what you need to do, you need to just draw this XY line and these points A and A dash. These are your answers except which anything is out of our concern now. So let us focus for this point. So whenever your point is in first quadrant, so what will happen? So let us see on the table on the left. So here the point is on HP and it is in front of VP. So whenever you are having any point on HP, then your answer would be on XY line like this. So your front view or your elevation view would be lying on XY line. So this is your A dash point laying on your XY line. So whenever your point is on HP, that means your view would lie on a XY line here. Second, it is in front of VP. In front means what? Whenever your point is in front of VP, then as you can see, top view would lie below XY line. So this is your top view, or without dash point will always lie below your XY line. So you need to remember that. Now let us see for second point. So let us suppose if your point is in second quadrant, but here as you can see from table on the left, your point is above HP but on VP. So at that case, if your point is above HP, then your front view would lie above XY line. As you can see, A dash point above XY line. And if your point is on VP, that means your top view would lie on XY line. As you can see, point A on XY line. So this is nothing but whenever your point is on VP or on HP, that means your answer would lie on what? XY line. So suppose your point is with respect to HP and resting on HP, that means your answer would be dash point on XY line. Suppose it is said that your point is on VP, that means your answer without dash would be on XY line. So next, for the third quadrant point, what will happen? So let us see, third quadrant point is on HP but behind VP. So for that our answer is whenever your point is on HP, that means your point with dash would be on XY line. Let us see, your front view would be point A dash on XY line. Now second, your point is behind VP. So whenever your point is behind VP, your top view would be what? Above XY line, as you can see from the table. So your final answer without dash A point or your top view would be above your XY line. Next, let us see for the final point which is in fourth quadrant. So this is the point in the fourth quadrant. So let us observe the table. So fourth quadrant point means it is below HP and it is on VP. So whenever your point would be below HP, your answer would be what? Your front view would be below XY line. So as you can see, your front view with dash point would be below XY line, and your point whenever is on VP, that means your without dash point would be lying on your XY line itself. So as you can see, your point A is lying on your XY line itself. So these are the answers you need to remember in examination. You need to finally draw this answer and you will have the marks. Now, it was too difficult to remember all these answers in table, right? Don't worry, I have compiled this table. So this is known as projection of points table, and you can say it is a shortcut to solve any of the examples of projection of points within a no time. Yes, within a no time. I will show it to you in subsequent sections when we will try to solve the examples, and you can solve any of the examples within just a second, right? So now let us try to understand this table first. So we are having total of two tables. These are nothing but your projection of points tables. So first table would be respect to your HP, as you can see, and second table would be with respect to VP. So there are two tables, first table for HP and second table for VP. So now whenever in your examination in the problem it is said that your point A is above HP, your answer would be what? Directly point A dash above XY line. So you need to just draw XY line and then you need to just plot your point A dash above XY line, right? Very simple. Whenever it is said that your point A is on HP, your answer would be A dash on XY itself. If it is said that your point A is below HP, you need to draw your A dash below XY line. Very simple. So now for VP, let us understand the table. So whenever it is said in your examination, point A is in front of VP, you need to draw point A below XY line as an answer. Whenever it is said point A is on VP, you need to just draw your point A on XY line. And finally, whenever it is said that your point A is behind VP, then answer would be your point A above XY line. So here understand, this point A dash represents front view or elevation. It is also called as front view or elevation of that view. Whenever it is represented with respect to HP, then it is known as the front view or the elevation. So A dash point is also known as a front view or elevation. Remember that. And here without dash A points is also known as your top view or plan. So whenever it is said that you need to draw the elevation or front view, that means you need to draw A dash. And whenever it is said that you need to draw the top view or plan, you need to always draw what? A without a dash, right? So you need to remember this table. So let me give you one trick how you can remember this table. So as you can see, for HP table it is very easy. The question would be above and answer would be above. In question on, answer would be on. And in the question that would be below, and here is also below. So it is same. So you need not to remember table for HP because it will be very easy for you to remember. You need to just remember the two terms. First, if there is in front in VP, then your answer would be below. And second, if it is behind VP, then your answer would be above. And here, as you can see, here on VP is also on XY line. So you need not to remember. So here, what you need to remember is this first one and this second one. So these are the two things that you need to remember. And after remembering this table, you can solve any of the examples within the notepad. So now, by keeping this table in mind, let us begin our very first example based on projection of points. So let us start. So let us first read the question. So projection of points. Draw the projection of points for following. So we are having total of 9 examples and we will be drawing all of the 9 examples on same XY line. So we are having the same XY line and we will be plotting all the 9 points on the same similar XY line. So now let us see how to start. So first let us read the first question. So first question says that point A is 40 mm above HP and 55 mm in front of VP. So as you can see from our table we can easily solve because here two data are given. One with respect to HP, so we will be using the HP table for that, and second data is given with respect to VP. So we will be simply using the VP table and we can easily solve the example. So let us see, we will be having point A. So we are dealing with point A. So point A means a capital point. It is a real object. It is our real object and we will be having two of its projections. First, the front view which is A dash, and second would be what? Your top view, which would be your point without dash, means normal A point. So we need to just plot 2 points on the straight line XY line. First point A dash and second point would be point A. So let us start first for point A. So point A is 40 mm above HP. So let us remember the table. Above HP means what? Above XY line, right? So let us plot our point 40 mm above XY line, which would be your point A dash, as you can see on most extreme left hand side with the red point, right? A dash point. So you need to draw this point 40 mm above your XY line and you will be having your point A dash on your XY line. Now next, the point is 55 mm in front of VP. So now point is 55 mm in front of VP. So we are talking about in front of VP. So in front means what? Below XY line is our answer. Point without dash but below XY line. So we need not. So here we need to draw your point A without any dash 55 mm below XY line. So let us draw point A 55 mm below xy line. As you can see on the extreme left, the first example we are dealing. So 55 mm you need to draw point A without dash, and you will be having point A with a blue color. So here our chapter is projection of points. That means you need to highlight your point by a dark point, and your lines connecting this point should be lightest as possible. So here in example, what you need to follow, you need to draw your xy line with a normal darkness, and you need to darken these points A dash and A little bit more, and the connecting line should be lightest as possible, because these are the reference line which are showing your projection of A dash and A would lie on the same vertical line. It is very easy. So let us see example number 2. So in example number 2, you can see point B is 10 mm above HP and 25 mm behind VP, right? So 10 mm above HP means 10 mm with respect to HP. So table, we need to check two tables with respect to HP and with respect to VP. So let us check first table. Above HP means what? Point with a dash above XY line. So here we are dealing with the point B, so that's why our answer would be point B dash, which would be above XY line. So we need to draw B dash 10 mm above XY line. So let us draw a point B dash 10 mm above XY line, as you can see on your left hand side by straight draw. Then after, what we are dealing with, 25 mm behind VP. So your point B is 25 mm behind VP. Behind VP means what? It is also the answer above XY line. So we need to draw your point B without any dash, which is also above XY line, because here behind VP, that means also what? Above XY line. So we need to draw this point B, which is 25 mm above XY line. So you will be having your point B dash and B on same vertical line like this. After that, we will be having a third point, point C, which is 35 mm below HP and 20 mm behind VP. So below HP means what? Below XY line. So we will be having point C dash below XY line, 35 mm below XY line. So let us draw point C dash 35 mm below XY line. Then after, it is 20 mm behind VP. So behind means what? Above XY line is our answer from the table. So we need to draw point C without any dash above XY line. So here point C, 20 mm behind VP, that means 20 mm above XY line. So we need to draw point C, which is 20 mm above XY line in this case. Very easy. You need to darken the points, and all else line should be lightest as possible. Now let us move to a fourth example. Point D is 10 mm below HP and 40 mm in front of VP. So 10 mm below HP means what? Your point D dash should be 10 mm below XY line. So let us plot a point D dash 10 mm below your XY line. Then after, it says that 40 mm in front of VP. So 40 mm in front of means, in front means what? Also below XY line. So we need to draw your point without dash. So point D would be 40 mm below your XY line. We need to darken the points except everything, and everything else would be lightest as possible. Now, then after, let us see example number 5. Point E is on HP and 50 mm in front of VP. On HP means what? On XY line itself, and with respect to HP means what? We'll be having answer with a dash. So your point E dash would be on XY line, and now 50 mm in front of VP. So in front means what? Below XY line. So point E dash would be 50 mm below XY line. So let us draw point E. So here point E is on HP and 50 mm in front of VP, right? So point E is on HP means your point E dash would be on XY line itself. So let us plot your point E dash on XY line itself. Then after, we are having 50 mm in front of VP. So we need to draw point E, which is 50 mm below XY line, because in front of VP means our answer would be below XY line. So let us draw point E, which is 50 mm below your XY line. Then after, let us move to example number 6 here. So point F is on HP and 80 mm behind VP. So now let us plot. First, point is on HP, that means on XY line itself. So F dash would be on XY line, as you can see, and which is 80 mm behind VP. So behind means what? Above XY line. So whenever your point is behind VP means your point's answer would be above XY line. So let us plot this point 80 mm above XY line like this. So this would be the final answer of your point VP. So 80 mm above XY line. So this is the final answer point without dash, and this is above XY line. Then after, let us see the example number 7. Point G is on VP and 75 mm above HP. So point G is on VP in this case. On VP means what? On XY line, but what? Without dash point would be on XY line. So we are having point G on XY line. Then after 75 mm above HP, 75 mm above HP means what? Above HP means above XY line. So we need to draw a point with a dash. 75 mm above XY line. So G dash point would be 75 mm above XY line. You need to make these points darker, and this line, connecting line, should be lightest as possible. Now let us see example number 8. Point H is on VP and 30 mm below HP. So here point H is on VP, that means your point H without dash would be on VP or on XY line, and 30 mm below HP, that means below HP means what? Below XY line, right? So your point H dash would be below XY line and it would be 30 mm below XY line. So 30 mm below XY line, this would be your final point H dash. Now let us see the final example, which is point I is on both HP and VP. So means what? Your point, both the views, your top view and front view would be both on XY line itself, because it is resting on HP and VP itself. That means your final views would be lying on the same line. So I dash and I would be same point on your XY line itself. So very easy. So try to solve this example by yourself by using the table. If you know the table, then you can easily solve this example, right? So let us move ahead and let us see one more example so you can know it better. So this is the table. So let us just refresh the table once again. So this is the table. First is your HP table, second is your VP table. On the left hand side column would be your problem statement and right hand side would be your answer. So if it is given point A is above HP, your answer would be A dash above XY line. If it is given that A is on HP, then your answer would be point A dash on XY line. If it is given that point A is below HP, then your answer would be point A dash below XY line. And for VP table, if your point A is in front of VP, your answer would be point A below XY line. If it is given that point A is on VP, then your answer would be on XY line. And if your point is behind VP, then your answer would be point A below XY line. So these are the answers that you need to remember this table. If you know this table, then let us move ahead and let us solve the next example. So here, draw the projections of following points on a common reference line, keeping the distance between their projectors 30 mm apart. So here the difference is what? Now we have to draw each of the examples by keeping the 30 mm distance between each of the projectors. So this is the difference. So projectors means we have to keep the 30 mm distance between each of the example. That is meant by the projectors. So this is a projector for the last example and this is projector for the previous example. So we need to keep 30 mm distance on this horizontal line while drawing these projections, right? So let us move ahead. So we are having a total of 4 examples to do. So let us see first example. Point A is 20 mm below HP and 50 mm in front of VP. So let us solve the first example on the most left. So 20 mm below HP means below XY line. So A dash point would be below XY line, and which is 20 mm. So you need to draw point A dash 20 mm below XY line. Then after it is 50 mm in front of VP. So in front means what? Also below XY line. So your answer would be point A below XY line, but here 50 mm below. So we need to draw point A 50 mm below XY line. So we are ready with A dash and A both on the one side of your XY line. Next, point B is in HP and 40 mm behind VP. So point B is in HP. In HP means on HP, both are the same. So whenever your point is on HP or in HP, your answer would be lying on XY line itself. So your point B dash would be on XY line itself, as you can see, and your 40 mm behind VP. So behind means what? Above XY line. So your answer would be without dash point above XY line. So your point B would be 40 mm above XY line. So this is your final answer. And we need to keep the distance between these two projectors of A and projectors of B 30 mm apart, because it is said that you need to keep the distance of 30 mm apart between these two projectors. Then after, let us move to a third example, which is what? Point C is 30 mm in front of VP and in HP. In front means what? In front means below XY line. So we'll be having your point C below XY line, which would be 30 mm below XY line, and point is in HP means your point C dash would be on XY line itself. So as you can see, point C dash would be on XY line itself. And you need to keep the distance between these two projectors of B and C, 30 mm as you can see. So you need to maintain that distance once again. Then after, let us come to our last example. Example 4. Point D is 50 mm above HP and 30 mm behind VP. So above HP means what? Above XY line. So let us draw this point D dash 50 mm above XY line like this. Then after, point 30 mm behind VP. So behind VP means what? Behind VP means also above XY line. So we need to draw point D without dash above XY line in this case also. So let us draw point D, which is 30 mm above XY line. So in previous example we haven't given any dimensions, but in this example as you can see we have to show each and every dimension. So don't forget to show dimensions in examination. If you forget to show dimension in examination, then you may have less marks in your examination. So these are the ways that you can show the dimension in your examination. So now let us move ahead. So once again let us refresh this table. So we have two tables with respect to HP and VP. You need to remember this table in order to solve any of the example based on projection of points, right? So let us move ahead and let us solve one more example. So projection of points. A point P is 50 mm away from both the reference plane. Draw its all the possible projections. So now your point is 50 mm away from all the points from HP and VP. So we might have a total of 4 positions. 4 positions in what? 4 different quadrants. Because it is 50 mm away from HP and VP. So we might have this point in first quadrant or second quadrant, third quadrant, or you can have this point in fourth quadrant. So we might have the 4 possible positions of this point. So we'll be plotting the 4 possible positions of this point. Now as you can see, this point is 50 mm away from X and Y. So we might have this point as P 50-50 because 50 in X and 50 in Y, because it is at 50 mm distance from X and also from Y. So let us start plotting the point first. So first we will be plotting this point for a first quadrant. So for first quadrant, what is the case? Point is above HP and in front of VP. Remember the quadrant system. So point A is above HP and in front of VP. So like that. So here our point P is above HP and in front of VP. So let us plot this point. So above HP means your point would be P dash above XY line. As you can see, P dash above XY line, 50 mm above XY line. And in front means what? Below XY line. So your answer would be P below XY line. So first equation we have solved. Now let us see for second quadrant what happens. Point A, point P is above XY line. Point P is above HP and which is behind VP. So whenever the point is above HP, that means you will be having your front view point P dash above XY line. As you can see, P dash 50 mm above XY line. And secondly, what? It is behind VP. Behind means what? Also above XY line. So your point P without dash would be also 50 mm above XY line, like this. So this would be your second answer for second quadrant. For third quadrant, point would be below HP and behind VP. So below HP means what? Your point P dash would be below XY line and behind VP. Behind VP means your answer would be above XY line. So your answer would be above XY line, as you can see. All of the distances should be what? 50, because your point is 50 mm away from your HP and VP. Then after, let us come to a fourth position. So in fourth quadrant, what happens? Your point is below HP and it is in front of VP. So whenever a point is below HP, your answer would be P dash point below XY line. And second, whenever a point is in front of VP, your answer would be obviously below XY line. So your point P would be below XY line, as you can see. So your both of the points would lie on the same spot like this, below XY line. This is an important example. You need to show points for each of the quadrant, and if you are too specific, then you can specify each of the quadrants under these examples, that examiner can easily verify your question. So examiner can easily verify your answers. So now let us move ahead. Let us see once again this table. You need to remember this table. As you can see, we are solving the example based on this table very easily. So first is your HP table, second is your VP table. Just remember this table, you can solve any of the examples. So let us move ahead and let us see one more example. So So this is the example. Draw the projections of following point, and we have A to G points. So let us start with first A point. So for A, point A is in VP and 20 mm above HP. So in VP means what? Point A would be on XY line itself. So here you can see point A is on XY line itself. Point is 20 mm above HP. Above HP means what? 20 mm. Point A dash would be 20 mm above XY line. So as you can see, point A dash is 20 mm above XY line. Let us see for point B, example number B, 40 mm above HP and 25 mm in front of VP. So in 40 mm above HP means what? Point is B dash, which is 40 mm above XY line, as you can see, and in front means what? In front means below. So your point B is 25 mm below your XY line. Third, example C, in VP and 40 mm above HP. So in VP means what? Your point C would be on XY line itself, and your point is above HP means what? Your point C dash is 40 mm above XY line. Then after, let us move to example D, 25 mm below HP and 25 mm behind VP. So 25 mm below HP means 25 mm D dash point would be 25 mm below XY line, and your point is 25 mm behind VP means above XY line. So your point D would be 25 mm above XY line. Then let us move to example E here, 15 mm above HP and 50 mm behind VP. So 15 mm above HP means what? 15 mm above XY line, so your point would be E dash, and 50 mm behind VP means what? Your point would be point E without any dash, and which is 50 mm above XY line here itself. So here point E is 50 mm above XY line, so this is your point E without dash, so you can see. Now let us move to example F, 40 mm below HP and 25 mm in front of VP. So as you can see, 40 mm below HP, you will be having your point F dash, 40 mm below XY line, and you will be having another point which is 25 mm in front of VP. So in front means what? Below XY line itself. So we will be having point F, which is 25 mm below XY line. And let us see the final example, example G, which is point G is in both HP and VP, right? So point G would be lying on same XY line, G and G dash would be lying on the same spot. As you can see, G and G dash are lying on the same spot. So that is all from my side. If you like my content and teaching style, do not forget to like, share and subscribe to my channel. If you have any doubts, any queries, feel free and comment down below. Keep learning, stay connected, bye bye.